Hello dear students, I welcome all of you to another sorting technique video, Insertion Sort. We will understand how insertion sort works with an example. Let's say we are given this array from location 0 to location 4. So there are total 5 elements in the array. That is size of the array n here is 5. There are 5 elements in the array and we want to sort this in increasing order. Now, what insertion sort does is that it starts with an assumption. The assumption is that the array is logically divided into two parts, the sorted part and unsorted part. Just check, the size of the sorted part is only one element, that is 0th element, that is 50. Only element is in the sorted part, and rest of the elements, as you see, 4, 2, 58, and 8 are in unsorted part. First of all of you must agree before going ahead that this portion is really unsorted because the elements are 4, 2, 58, and 8. Obviously, this is unsorted. And you also must agree that this part, which contains only one element, is sorted. Come on, this particular part contains only one element, that is 50. Then it is sorted. Suppose I give you one array of only one element, that is 0 element, and it is storing 50. And I ask you to sort this. You will say, come on, sir, this is sorted. This contains only one element. So that's what is my point, is that the part which contains only one single value is indeed sorted and rest of the array is unsorted. Now let's see what insertion sort does in pass 1. In pass 1, insertion sort will take the first element as it is pass 1, that is 4, and it will try to insert this 4. Okay, that's the word, insertion sort. It tries to insert this 4 in the sorted part so that sorted part will remain sorted. Now you only tell me 4 has to be inserted in the sorted part. Then shouldn't 4 go above 50? Of course. Only then this portion will be sorted. But how can you put 4 above 50? Because that location will be minus 1th location. It sounds funny. There is no such location in the array. So how are you going to really pick this 4 in pass 1? That is first element. And how are you going to insert it in the sorted part so that sorted part remains sorted? Of course 4 should go above 50, no doubt about it. But then what you do is you tell 50 anyway you are heavier than 4, so I will pull you down and let 50 occupy the place of 4. So note that at the first element initially 4 was stored, but now that place has been taken up by 50. And now this 4, the value 4 can safely go at place 0 because you can understand that 50 is as good as not there here because it was pulled down. So place 0 was anyway empty and 4 has been inserted at place 0. That's it. That is what pass 1 does. So at the end of pass 1, the array elements are 4, 50, 2, 58, and 8. As you all see, the first two elements are sorted. Indeed, these are sorted. So this is the sorted part now. Initially, the sorted part had only one value, but now the sorted part has two values and rest of these elements from 2 onwards are unsorted. So that is what happens in pass 1 and has been described over here. As you can see, you can go through this later, it has been described. This is the array that we are having. You watch 4 and 50 as you see. 4 and 50, these two elements are now sorted. Now what happens in pass 2, let's see. In pass 2, as it is second pass, we will take the second element, that is 2, and try to insert it in the sorted part so that sorted part remains sorted. So what we do is we tell 50 anyway you are heavier than 2, so you better take yourselves down by one place. So 50 is copied at the second place. And then we tell 4 you are also heavier than 2, so you also get pushed down by one place. So 4 occupies the first place. So 50 is not there at first place, 50 has been pushed down to second, 4 has been pushed down to 1, and now that value 2 will now safely go at 0th place. That's it. That is what is done by pass 2. So the array elements after pass 2 is 2, 4, 50. Notice 0 to 2 elements now are really sorted. These are in sorted order. And what rest remains is third and fourth element, which is 58 and 8. So that has been shown here and explained, and this is the array that we have after pass 2. Note that 2, 4 and 50, these elements are now sorted. Now let's see what happens in pass 3. Very interesting. Just check. In pass 3, we take the third element, isn't it? That is 58. And we try to insert it in the sorted part. So that sorted part will remain sorted. But just check, just by comparing 58 with the element just above it, that is 50, we observe that 50, the element above 58, is already lighter, smaller than 58. Then surely, this value 58 is at correct place. You don't have to push down any values. Well, how many comparisons you did for announcing that 58 is okay at third place? No need of rearranging the values. You did only one comparison. You did just one comparison to announce that 58 is at proper place. You will easily understand it. You see that 58 is greater than 50. Then 58 has to be greater than all the previous elements. Come on, these previous elements are already in sorted order. So that's great. If the element is already at its proper place, then only one comparison is enough. That's it. This is pass 3. Pass 3 has ensured that 58 is at proper place. So this is the array after pass 3. Let's see. You can see that now 2, 4, 50, 58. All these elements are sorted, and now pass 4 will take the fourth element, that is 8. Where should 8 go in the sorted part? It's very easy that 8 should go between 4 and, yes, between 4 and 50. So how this comparisons will be done in pass 4? Listen, we want to insert 8. So we first ask 58 to go down because it is heavier than 8. Then we ask 50 also to get down by one place because it is heavier than 8. And now we ask 4. Oh no, 4 cannot be pushed down because 4 is lighter than 8. Then 8 gets its proper place at second position. You see that the array after pass 4 is 2, 4, 8, 50, 58. And all these elements from 0 to 4 now are in sorted partition and nothing remains unsorted. So the array is sorted. So how many passes were really needed? Did you count it? We needed 4 passes. And the number of elements in this array were 5. So when n was 5, size of the array, when n is 5, the number of passes needed are 4. So in general, for n elements, how many passes will be needed? We will need n minus 1 passes. Same as selection sort or bubble sort, we will require n minus 1 passes. Let's take one more example of insertion sort before we see the algorithm. Let us take some values in the array A. Let us say that the values in the array A this time are 15, 4, 18, 12 and 8. It is again a 5 element array, goes from 0 to 4. So n is 5. Now you know that the insertion sort starts with an assumption, sorted and unsorted. And in the pass 1, we will take 4 and try to insert it, first element in pass 1. And as 15 is heavier, 15 is pushed down. And then 4 safely goes at 0th place. So you understand that after pass 1, the elements of the array are 4 followed by 15, isn't it? I'll just check this. After pass 1, the array elements are 4 followed by 15. Now, these two elements are sorted after pass 1. Now, pass 2 will take the second element, 18, and here we go, 18 is already at proper place. You don't have to shift down any values, but you will do only one comparison. You will compare 18 with 15. And as 18 is greater than 15, you know that 18 is definitely greater than all the previous values. So great. This ends pass 2, and pass 2 has inserted 18 at proper place, that is at second place. Now starts pass 3. In pass 3 we will pick 12 and try to insert it in the sorted part. But the previous element 18 is heavier, so we'll pull it down. Previous element 15 is also heavier than 12, so we'll pull it down. And now 12 will safely go at the first place. 4 can't be pushed down because 4 is lighter than 12. So now the array elements after pass 3 are 4, 12. What did I do? This was 15. I'm so sorry. Yeah. 4, 12, 15, 18. These are the array elements up to third place. This is sorted and only 8 remains now as unsorted. Now pass 4 starts fixing fourth element. 18 is heavier, so let's pull it down. 15 is heavier than 8. 12 is also heavier than 8, so pull it down by one place. And now 8 gets its place at first location. 4 can't be pulled down because 4 is lighter than 8. So fourth element also is fixed at proper place, then the entire array is sorted. I hope you got the idea about process of insertion sort. Now let's see the algorithm for insertion sort. The algorithm here has array as the parameter which we want to sort and size of the array. Now you can easily understand that in the algorithm the for loop starts with I equal to 1 and not with 0. You know that the array begins with 0 index, but we are starting I with 1. That's because you know that if we are having some array like this 15, 12, 18, 18, 8 and let's say 11, this is the array, then you know that we start with an assumption that 0th element is sorted. So our process starts with first element. So I must begin with 1, obviously. Let's see what happens when I is 1. In the for loop, we store x is equal to ai. Now ai here means 12, isn't it? A1. So here x, the another variable, is storing the value 12. Nothing. What we have done is we have safely stored this value 12 in a safe variable x. Okay. Now we are using one more variable j which begins with I. So as I is 1, j is also 1. And now we hang on in this while loop. This while loop will check two conditions. It will run only if j is positive, j is greater than 0, which is true at the moment because j is 1, and logical and a of j minus 1 should be greater than x. Only then this loop will continue. Now a of j minus 1 here means a0 clearly because j is 1, and observe a0 is 15. We are asking, is that 15 greater than x? X is 12. So what we understand, this is true. What we understand is that if we want to fix 12 in the sorted part, then the element just before it, j minus 1th place, that is just before it, is greater than 12. So this 15 should be pulled down, isn't it, by one place. By the way, both the conditions in the while are true. So we are entering the while loop and executing the statements of the while. So what happens when the while runs? This statement aj is equal to aj minus 1 here would mean a1 because j is 1 is equal to a of j minus 1 means a0. That is pushed down. This statement is push down operation. Literally a1, here we go, a1 becomes equal to a0. 15 is pushed down. So this aj is equal to aj minus 1 is the push down operation. The next line here is j minus 1. So observe that j in our array indexing was 1. But now j will reduce to 0. J reduces to 0. And now this while loop, observe this while loop will end because this while loop repeats only if j is positive. But j has become 0. So this loop breaks. And when the loop breaks, we are certain, we are sure that we have found place for 12. The best place for 12, that is x, is aj. J gives you best place for x. And aj here means a0 because j has become 0, will become x has been written. So this element, 0th element, will store the value 12. That's it, 12 has been inserted at proper place. And then the for repeats. For will take up the next element to be fixed. This goes on. This goes on. You can try with an array, and you can put your values of the array in the while just as I did. And you can understand how this for loop repeats all over to fix 18 next time. Then I will become 3, it will fix 8, resuming with the while loop, repeating and push down a few elements. This is how the algorithm of insertion sort is designed. Thank you very much.